Okay, so the dog is still asleep, and I have time just for a few slides to wrap up this first lecture. So let me share my screen. And we're summarizing these concepts that I've introduced with some tips for efficient prompt and context engineering. Let's go through the common mistakes that we've talked about earlier in this lecture. For example, not specifying the format. You need to, in your prompt, specify the structure of the response that you want. Another common mistake is asking lots of questions in one prompt. It's much better to focus on one clear task and then stage your prompts so that after you've got one, then you go on to the next question. We've talked about how important context windows are. They're really crucial because otherwise the whole conversation can just degenerate and get frustrated. Monitoring token usage is important. Although you're not charged according to tokens for pro users like us, you can always ask how many tokens have we used so far in this conversation. It'll give you an estimate, a rough estimate anyway. And if you know how big your context window can be, for example, 200,000 tokens for Claude, and if you get near that, then you should ask it to make a summary prompt, a summary response, so that it doesn't get dropped out of the context window. Another common mistake is that some people just make a sort of similar one-size-fits-all prompts. It's much better to be as specific as you can in a token-efficient way, depending on the role you want it to play, the target audience, and so forth. And if you're using in-context learning, so few-shot learning, for example, instead of doing very similar cases and not trying some borderline cases of whether it's in the sentiment example we used, we should have given it guidance maybe for some really borderline, whether the sentiment is positive or negative. So try lots of different inputs. And instead of forgetting about the cost, you need to optimize for efficiency, even if you're not paying per inference cost, as professional developers are. It's still bad for the planet if you use too many tokens. So good prompting is both an art and a science, just like any mathematical modeling of financial markets. It requires creativity, precision, and systematic testing. This is a nice slide written by Claude. You know, I uploaded the first deck that I made to ChatGPT and Claude and asked them to criticize it and suggest improvements. ChatGPT completely failed. First of all, it told me it made improvements, it hadn't changed a thing. And then it said it had done these improvements. It didn't recommend many improvements. And it sent me 2 slides. And Claude did the whole thing immediately really, really well. Obviously, I spent probably hours and hours refining what it had done, but it definitely improved this presentation in Beamer. So this was one I didn't change at all. It's a nice Claude slide. Tips for good prompt and context engineering. First of all, be specific, but also be concise. Vague prompts lead to vague outputs. Write something about climate versus write a 300-word explanation of greenhouse gases for secondary school students, right? You know you're going to get a much more targeted and focused response. Make sure you consider your audience always. Explain like I'm a 10-year-old or explain for a PhD audience. Provide plenty of examples. Show the model what good output looks like. Few-shot prompting. Establishing patterns. Set constraint. say in 200 words, no more. Put in your requirements for format, tone specification, temperature. Respond in exactly 3 bullets, each under 20 words, for example. And your first prompt is not going to be your best. Keep refining based on the outputs until you get the best the response. Don't just take the first one. How do you evaluate your prompts and the context? Well, it depends on the responses. Does the output directly address your request, or is it giving you a lot of redundant information? Is it correct? Is it hallucinating? This is very, very common, so you definitely need to check that aspect. How consistent is it? Do similar prompts produce similar quality outputs, even if the temperature is turned up and they're very different? Is the quality always similar? Or does it hallucinate sometimes and sometimes not? Are you able to get good results with just a few tokens? And are your prompts useful for other people, or is it just you that can use them? So a practical tip is to create a test set of prompts, evaluate outputs on that test set systematically. You might do as I did and test GPT-4 against Claude 4. It's very clear to me that in the last month or so, OpenAI have been putting a lot of effort into the GPT agent and very little effort into GPT-4. Whereas Anthropic are really developing well, and it's easier. It's not a GPT. Claude is just an LLM that works in a very different and ethical way. We'll talk about that more in later lectures when I drill down into specific tools like NotebookLM as well as the Anthropic and OpenAI offerings. Anyway, so there's a whole new science, I think, about to emerge about evaluating prompts and contexts. You could use metrics like response time, token usage, accuracy scores, user satisfaction. So I guess that the developers of these LLMs are already using those metrics, but for somebody who's hoping to help young people use these lectures so that you're not going to be unemployed, even though you're a white-collar worker, then you can use your own metrics and press your boss. Start looking at these things, okay? So, to summarize the key takeaways from this first lecture. Prompt and context engineering are different. Prompt engineering is about crafting individual messages. Context engineering is about designing entire systems. Tokens matter. Every word costs money, costs energy. Efficient prompting is both economical, because you're charged by tokens if you're a professional user, and good for the environment if you're mindful about the tokens that you use. Context window and memory, actually. I haven't talked much about memory here. I will do in lecture 3 on context engineering. But context windows are finite. They can only contain a certain number of tokens. So plan your conversations. Manage memory strategically. If it looks like you're near the limit of whatever it is, 128,000 tokens for GPT-4, then get a summary so that it doesn't forget. Temperature controls creativity. You can match the setting to your task requirements. Hooks enable persistence, not exactly memory, but reusable, customized LLMs can use hooks rather than starting from scratch each time. And finally, your first attempt is rarely your best. So whenever you're using these LLMs, then test and iterate before you take away a response. Okay, well, I hope you enjoyed these lectures. Well, this first lecture in 4 videos. And I hope I get time to upload lecture 2, which is about prompt engineering using Anthropic Console, a practical guide. Bye for now.